Welcome to AI Frontiers. Today's episode, titled AI at the Cutting Edge, Machine Learning Advances from cs.LG, explores 64 breakthrough papers that are shaping the future of artificial intelligence. In this journey, listeners will discover how research is powering smarter, leaner AI, covering topics such as model efficiency, interpretability, and more. Special attention will be given to the standout work, DGTN by Lin and colleagues. Whether you are an enthusiast, developer, or researcher, these insights are tailored for you. Did you know that training a single massive language model can consume as much energy as a small town uses in 1 week? This hidden cost and the promise to reduce it are central to today's research efforts. Cutting-edge work now aims to halve these resource demands without sacrificing model capability. Listeners are now at the frontier of smarter and greener AI, preparing to learn about the breakthroughs that will drive tomorrow's technology. Machine learning research is transforming daily life and scientific discovery. Artificial intelligence now recommends what to watch, helps diagnose diseases, translates languages, and even drives vehicles. The field evolves at an unprecedented pace, with new ideas emerging every month. This episode provides a focused snapshot of that rapid progress by highlighting 64 papers published in a single day. By the end, listeners will gain a clear understanding of the trends, breakthroughs, and challenges that drive smarter, faster, and more trustworthy AI. The cs.LG category stands for Machine Learning in Computer Science, as found on the arXiv preprint server. Think of it as the bustling main square of the AI research city, where towering skyscrapers symbolize large models and quiet neighborhoods represent new algorithms. Machine learning itself is the science of enabling computers to learn from data, not just fixed rules. These systems often improve unpredictably with experience. The field resembles a city that never sleeps, always building and always innovating. A major research theme is model efficiency and scalability. As models grow ever larger, their resource demands increase dramatically. Researchers are now working to shrink these models without losing their power. For instance, the MoSKA architecture by Lee and colleagues redesigns the attention mechanism to be more memory efficient. This is akin to replacing a car's heavy steel frame with carbon fiber, achieving a leaner structure while maintaining strength. The core technical concept here is the attention mechanism, which determines how models focus on relevant parts of the data. Interpretability and explainability are critical themes in modern AI. Trust in machine learning models requires understanding how decisions are made, which is especially important in healthcare, finance, and other safety-critical fields. The Beyond Redundancy paper by Chen and collaborators introduces diverse and understandable autoencoder features. This is comparable to a chef who not only prepares a meal, but also explains every step and ingredient. Technically, autoencoders are models designed to compress and reconstruct data, making learned features more accessible and interpretable. Cross-domain and transfer learning enable models to adapt knowledge from one field to another. The LLM attention transplant study by Wang and co-authors demonstrates how learning can be transferred across different datasets, much like a pianist who, armed with shared musical skills, finds it easier to learn the violin. This capability allows rapid progress in new problem spaces. Transfer learning as a concept leverages prior knowledge to accelerate learning on new tasks, making AI more versatile. Several mini-stories of discovery emerge from the 64 papers reviewed. The DGTN model by Lin et al. Enables sequence and structure models to communicate, significantly boosting predictions in protein science. The MoS framework by Zhang and team uses FP8 precision to reduce training time by 34%. Fusion log by Li et al. Combines different log types to detect system failures even without labeled data. ProDer by Wang and colleagues brings continual learning to smart grids, allowing adaptation over time. Finally, Kim et al.'s work, predicting the future by retrieving the past, improves forecasting by matching current data to similar historical patterns. The featured paper of the day, DGTN by Lin and colleagues, addresses the challenge of predicting protein stability from both sequence and structure. The mission is to determine how mutations affect protein stability, specifically enzyme DDG. Proteins consist of sequences, like beads on a string, and three-dimensional folded structures. Traditional models have treated sequence and structure separately. Lin's team asked whether interaction between these two domains could improve predictive accuracy, which represents a crucial goal for protein engineers and drug designers. The DGTN model operates by fusing graph neural networks, which capture structural information, with transformer architectures, which process sequences. Information is allowed to diffuse between the graph and the transformer, so each informs the other. This process is analogous to two detectives, one with a map and the other with a suspect list, working together to solve a case. The authors provide a mathematical proof that their diffusion process leads to more effective representations. The technical concept of diffusion here refers to information spreading across different model components. DGTN demonstrates over 6% improvement versus competing models on public datasets. A central challenge addressed by the team was balancing information sharing to prevent uncontrolled feedback loops, also known as spirals. An insight from physics, specifically heat diffusion, helped solve a critical convergence issue. This breakthrough paves the way for faster and more cost-effective drug discovery and enzyme engineering. Furthermore, the architectural blueprint for fusing different data types holds potential for application in chemistry, social networks, and beyond. Looking ahead, the future of machine learning is filled with hopeful analogies. Models are becoming as efficient as hummingbirds and as transparent as glass. There is a growing trend to blend data-driven learning with established domain knowledge. Leaner and more adaptable AI promises to serve a broader community with advances in trust, privacy, and continual learning. However, ongoing battles remain, maintaining interpretability, fairness, and resistance to bias and adversarial attacks. Importantly, the next breakthrough could emerge from anyone, including listeners of this podcast. In summary, recent advances span efficiency, interpretability, continual adaptation, and the fusion of domain knowledge. The DGTN model by Lin and colleagues exemplifies the potential for breakthroughs in protein prediction. Machine learning is evolving to become not just smarter, but wiser, with a stronger grasp of context and the ability to explain decisions. Listeners are encouraged to explore the referenced papers. Links are available in the show notes. Stay curious. Share your ideas and become part of the vibrant city of machine learning. This episode was produced through a collaborative process combining AI tools and human expertise. The synthesis of research papers was powered by GPT, specifically the OpenAI GPT 4.1 model. Text-to-speech was provided by OpenAI, and images were generated using Google's tools. All content was reviewed by human experts for clarity and accuracy, though occasional oversights may remain. References are provided for each claim. The aim is to ensure transparency and ongoing improvement in the content delivered. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.